first public testnet of the merge, Kintsugi, is live. If you want to learn about the improvement proposal implemented in the clients for the merge upgrade, continue watching. Welcome to another merge special episode of PEEPanEIP, an educational video series where we learn about an Ethereum improvement proposal, upcoming updates, and the basics of Ethereum blockchain. I'm your host Pooja Ranjan, and today we are going to have an overview of EIP-4399 Supplant Difficulty opcode with Random with our very special guest, Mikhail Kalinin. Thank you for joining us, Mikhail.
Hello, everyone. Thanks, Pooja.
So Mikhail is an Ethereum developer working on the merge upgrade, EIPs, and implementation. He is one of the co-authors of the EIP-4399, a core proposal proposed in late October this year. And this proposal is expected to be deployed on the mainnet with the merge upgrade. Previously, Mikhail joined us on the show to explain EIP-3675, which is upgrade consensus to proof of stake. That is another very important proposal for the merge, and it is highly recommended to watch episode 41, that is PEEPanEIP 3675, before watching this episode to get a better context of EIP 4399. I'm super excited to follow what he has to share with us today. So without further ado, let's peep in.
Thanks a lot for introduction. So this one is 4399. And yeah, it's not gonna be like too long presentation today. So let's start. So we're starting with the header, and one of the co-authors, as Pooja mentioned, the other one is Daniel Ryan. Most of you are familiar with him. Also, this EIP depends on 3675. So it's outlined and it requires section of this header. What this EIP is about is basically the specification says that the return value of the difficulty opcode that is existing today is going to be supplanted by the output of the randomness beacon provided by the beacon chain. And this will take an effect since the merge, since the transition block. So it will start working after the network is upgraded to proof of stake, literally with the first block produced in the proof of stake network. So the motivation is twofold here. First of all, we'd like to expose the randomness that is accumulated by the beacon chain to the application layer, and hence the opcode is required to allow for access to this randomness inside of the EVM. And the other thing why it's implemented this way, why the randomness output supplants the difficulty value that is exposed by the difficulty opcode, is to avoid breaking the existing applications that depends on the difficulty as a source of randomness. So that's the motivation behind this EIP and behind this specification. So the next one is the dependency. Let's just go quickly through the dependencies on the 3675 here. So the transition block, as it's been mentioned, is literally the first proof of stake block in the system. And this is where this EIP 4399 takes the effect. Also, the main EIP, the main merge EIP, which is the upgrade to proof of stake, specifies the upgrade to proof of stake, has this table of deprecated fields. They are just deprecated by a set to their respective constant values. And there is the note below this table, which just says that this These fields, these constants, these fields will be used in the future. So these constants may be replaced by some real values. And this is what happens for 4399. The mixed hash value, the mixed hash field is reused to keep the randomness output value after the merge. So the specification basically is pretty straightforward, and it can be outlined in just one slide here. Thanks for Tim Baker for the original diagram here. So what's on the left side, we can see what's happens in the current mainnet before the merge. There is difficulty opcode that returns the value of the difficulty field, which is in the work blocks today. And what's on the right will start happening post merge, literally with beginning with the transition block. The execution layer payload or execution layer block will contain the 256 bits of randomness in the mixed hash field. This is like the field number 13, zero-based in the block structure. So it will hold this randomness output. And this randomness output will be exposed by the opcode with the number 0x44, which is difficulty opcode, and the mixed hash and the difficulty opcode are renamed to random. So the motivation of why, the motivation behind the rationale behind why to use the mixed hash instead of difficulty is the following. The difficulty is in the essence of the fork choice rule before the merge in the proof of work network. And this way, by keeping it zero, literally zero, we try to avoid hidden bugs in the fork choice rule that might appear if this field would be set to any arbitrarily large number, which is the randomness output is. So instead of this, we use mixed hash. The mixed hash is not used in the code base that much as difficulty in the code base of the existing Ethereum mainnet clients today. So that's why it uses the mixed hash and not the difficulty field. So let's move on. Yeah, there is also a small side effect. If anyone would like to create a smart contract that for some reason will need to distinguish the proof of stake world from the proof of work one, this EIP offers some trick to do this. It's based on the fact that difficulty values in the proof of work network are limited by 64 bits size. Actually, it's like 56 or 57 bits. I don't remember the exact number here, but doesn't that much matter. So you may use you may analyze the return value as the difficulty opcode, and if this return value is greater than 2 to the power of 64, it would indicate that the transaction is being executed in the proof of stake block. And if it's lower, then that must be the proof of work block.
And how long did you say that the random number is?
The random number is 256 bits long.
256. So shouldn't there be in terms of the number being lower than 2 to the 64th, shouldn't there be a chance that if the number is lower than 2 to the 64th, that it is actually the random number?
Yeah, I see what you mean. There is a very low, drastically low probability that the random number will hit the range of values that is below this boundary. So okay. It's pretty safe to use it. Okay, so let's move to the backwards compatibility section, which is, I think, very important here. So obviously, this EIP introduces backwards incompatible change to the protocol itself because it changed the semantics of the opcode, and it changed the block structure, the semantics of the mixed hash field. This is related to 3675 pretty much. So they are like pretty tightly coupled, these two EIPs. But what might be more important is that this EIP introduces the backward incompatibilities to the application level. So if there is any smart contracts that use the difficulty field as the real proof of work difficulty, they will no longer function normally. But this is actually does not relate to the 4399, but it rather relates to the getting rid of proof of work at all. And this is basically what the 3675 does. That's what not likely introduced only here by this specification. The other thing that bears in mind is that it might be the case that the application is designed in a way that it relies on the difficulty on the difficulty return value to be relatively small. So as it's been mentioned, it's limited by 64 bits. It might be the case that once this opcode will start to return the value much bigger than this limit, the 256 bits randomness outputs, something will go wrong with some applications that are not well designed. It may cause underflows or overflows. This will we are considering that this kind of applications, if they even exist, are by design that does not consider them as the obstacle to have this change. The next is 36.7. The next, which is outlined here, I think it makes sense to put all randomness stuff on one slide. Just want to remind that the block hash of code will not anymore, the values that is returned by block hash of code since the merge happens, they will not be anymore secured by the proof of work seal. So if the application used the block hash as a source of randomness, it will become manipulable by the block proposers. And to summarize the compounding effect of this, two EIPs. The compounding effect is as follows: if your application used the difficulty to obtain a real proof of work difficulty, it will be it will not operate normally after the merge, obviously, because there is no proof of work. Then if your application used the block hash and only a block hash to obtain the source of randomness, it will be easily manipulated by the flow of the way that it works will be easily manipulated by the proposers. And if your application uses the difficulty opcode, mixing it with any other source of randomness as a source of randomness, it will continue to operate normally, and we'll get this weekend chain randomness after the merge. So that's the summary. I'd take a short break here before we go to the randomness discussion, what the mechanics of randomness on the beacon chain and what the properties does it have.
So I had a question on the backward compatibility we just discussed. So as per the EIP, the backward incompatible changes to execution and validation of EVM state transition. And you just talked about the projects, those can be affected with that. Do you have any project in mind, right, which could be affected with this change to POS?
As been said, if any application uses the difficulty as the real difficulty from the proof of work world, it will be affected. If the application relies on the block hash and only on the block hash as a source of randomness, it may be affected because the block hash is like it becomes malleable after the merge because it's not secured by the proof of work seal anymore. So it's really easy to to remove or add a transaction and get completely different block hash, which will affect the output of this or that transaction that uses block hash as a source of randomness. So these two main things that are affected.
All right.
So yeah, but if your application uses block hash plus difficulty plus anything else, to obtain the randomness, it will still function. It will still keep functioning normally, and it will not be like as malleable as if it was using only the block hash of code.
All right, so it means that if it is only using one function, dependent only one function for generating randomness, then it can be affected. But if the project is using multiple functions, then there should not be major effect on the project.
Yeah, if it uses difficulty in any way to obtain randomness, even if it's mixed with block hash, with timestamp or whatever is people use to get randomness, yeah, it will not affect it, and it will yeah, it also, yeah, well, of course, it depends on how it's designed. Yeah, but
thank you.
At least it will get the same. At least it will get the same guarantees that the block hash, or even more. That the block hash before the merge. Yeah, we will just talk about it like in on the next couple of slides. And yeah. What are the odds here? Anything else before we move on? Okay, so randomness. Yeah, that's all for this EIP. It's pretty straightforward and easy to be understood. Yeah, and now let's talk about the randomness, which is offered by the beacon chain. So first of all, yeah, the RANDAO mechanics in a very simple way. So you may see here that there is the each beacon block contains the RANDAO reveal, which is revealed by the proposer of this block. Yeah, even before the merge, it's already happening. The RANDAO reveal is already in place in every beacon block, and it will continue to be the same after the merge. This reveal is the sequence or the chain of these reveals is then used to produce the randomness output. So it's basically the reveal is hashed, and then all the reveals, all the hashed reveals are XORed, and this and the product of this operation of this chain of XORs is called the RANDAO mix, and this is what actually returned by the random opcode after the merge. So yeah, first of all, the reveal is the signature, and each proposer of each block signs the number, the epoch number, with its private key, and that's basically the reveal. There are some other input parameters, but this is what makes the most sense. So it's the signature, and we assume that propose that validators picks their private keys in a really like using the very secure randomness. So it gives the very high randomness properties to these RANDAO reveals, and they can be verified. So this is basically, each reveal is the output of the verifiable random function. And all these XORs and the RANDAO mix is the output of the verifiable random function. So it can be like literally from the very beginning, from Genesis, it can be verified. All these RANDAO mixes, if you know the all validator sets till that time. So if the random code is called in the block number, say number 2, then the return value will be the RANDAO mix computed with the RANDAO reveal from the previous block, from the block number 1. That's it. That's how it works. So it's the random returns the previous RANDAO mix, not the one that is computed within this block, blocks reveal. So there is the reason behind this, but it doesn't that matter much here. Also, at the end of each epoch, the RANDAO mix at the end of each epoch is called seed. So this seed is used to sample validator sets and attestation committees and so forth, and it's used by the beacon chain itself. Yeah, but seed matters. So that's the high level mechanics of how does the randomness is obtained on the beacon chain. Yeah. So the next one is like the properties. So first of all, this RANDAO is biasable, but it's pretty limited in that regard. So what can happen here? You see these empty blocks and empty reveals. So if the proposer see that it will get some benefit from not revealing the RANDAO, and not revealing the RANDAO means that it does not propose in a block. So the opportunity cost here includes the proposer fee, includes transactions fee, and yeah, MEV after the merge. And for this cost, it may decide to not propose a block, and this gives the proposer one bit of manipulation power. So it may, in theory and in practice, it may produce 2 different RANDAO mixes. One is with his current RANDAO reveal that is about to be revealed in the block, or the one without his RANDAO reveal because he is withholding the block, withholding the proposition of the block. It may happen that some party owns more than one validator, and these 2 validators propose in consecutive slots. And in this case, this party will get like 2 bits of manipulation power, so they can in practice produce like 4 different RANDAO mixes by playing with these empty slots. And yeah, one is empty, another one is contains the block, and vice versa, and so forth. So 4 different outputs may be produced in this case. But if these empty slots that were made on purpose to avoid revealing the RANDAO is followed by an honest proposer that proposes that reveals his RANDAO, then this like kind of doesn't make much sense for these 2. This will not have then an further effect. So this like sequence is like broken here. So that's how it could be biased. There is, yeah, just to remind that the size of the output is 256 bits, and 1 bit can be 1 bit of manipulation power is behind each proposer. So it's not like that big. Of course, it depends on the number of the outputs that the user of this randomness oracle has. And yeah, it depends on the application of this randomness. Also, what was mentioned here is that, yeah, all this RANDAO has the limited look ahead, which is outlined below. And obviously, what's already published, what's already accumulated by this time as yeah, the random mix that is already published is 100 predictable, so it's just unsafe to use it. But what's not that much predictable is the future RANDAO mixes, the future mixes that computed with the future reveals. And here, for example, if we take a look at the above diagram, if we say that the random opcode uses the random mix generated by the block before, so at the time of block B1, it's not yet known what will be the RANDAO reveal of this block before, and it can be like, yeah, to get this value, the one will need to ask the proposer or bribe the proposer to reveal its RANDAO. Of course, the proposer knows what's RANDAO reveal it will have in the next block, but yeah, but this like kind of look ahead into what RANDAO reveals will occur in the system is very much limited, and this limit is it's limited by the set of proposers that will be assigned to some future epoch. So if you look at the diagram below, you can see that the seed, which is the RANDAO mix at the epoch boundary, the seed at epoch number n, is used to sample a set of proposers for epoch n+2, and it means that if you're in the epoch n, you even the set of proposers for epoch now n+3 does not exist yet. And you can't even know which proposers will reveal their RANDAO contributions, RANDAO inputs during this epoch, and this fact can be used to design the more secure applications that use this random opcode and this RANDAO outputs. So yeah, let's go to the example. So the mechanics of a smart contract that use random may look as follows. Suppose it's a lottery or any other logic that depends on the randomness. And smart contract is deployed some epochs, m epochs before the n epoch, and starts to accept bids. After beginning of the epoch n, bids are no longer accepted, and during the 2 epochs after, the results, whether it's lottery or any other kind of stuff, the result is drawn using the called random opcode. What's the rationale behind this design? So yeah, that's the look ahead limitation. So before the set of proposers, the set of RANDAO reveals is known, or the set of proposers even exists. These players who can influence the who can gain something from influencing the randomness 2 epochs after, they even don't exist, and they have no incentive to participate in this lottery. So that's why it's pretty safe, and that's the rationale behind this design. And yes, let's just try to imagine how it can be gamed. So one may bribe validators of a few epochs to get their RANDAO reveals in advance. This can give the understanding of what the proposer set will be, and by bribing all the validators from the proposer set, basically it's theoretically possible to get this exact RANDAO mix that will be used to draw the results of this application, of this lottery. And in all this sequence, one honest proposer who not get bribed, or who is not bribed, will be enough to make this RANDAO mix that will be used in the future unpredictable. Also, there is the incentive to introduce the slashing condition for earlier RANDAO reveals. So if it will be pretty unsafe for the proposer to reveal his RANDAO beforehand to any party in the network that can use this to slash this proposer. Also, the other way that it could be gamed is like suppose you know the validator set. You will know this validator set like after epoch number n, when the seed of epoch number n is known to the network, and you may try to bribe the key validators at the end of epoch, or before the that they have the influence on the RANDAO mix that will be returned by random opcode, like k validators, k last validators that reveals the RANDAO contributions before the call to random opcode, and try to get some manipulation power out of this, and try to just bribe them to not propose a block, and that's it. So that's pretty much, yeah. That's also bear in mind that you have like not that much time, because each epoch is like 6 minutes and a half. So it's not practical, I would say. So it's not practical to game this kind of application. So the cost of this is relatively high. Also, to reduce the biasability property, there is a VDF research. The link will be in the resources. So the VDF, basically the verifiable delay function, will significantly reduce this biasability vector. Yeah, that's all. Yeah, that's all from my end. Any questions this far?
Thank you. Thank you for this wonderful presentation, explanation of the process with the help of flow chart is like super helpful. The one with generating randomness and RANDAO properties literally took me to the college days. I mean, I'll admit, it's been a while since I have looked into or participated into development work, but the use of operator and explaining the process flow, it was awesome.
Yeah,
thank you.
Yeah, sorry for a little bit mess in that, because yeah, it's like a bit complicated thing. I mean, these.
No, I mean, that's super helpful. Actually, people having a little bit of background knowledge may be able to understand that in a better way. So thank you. It was really helpful.
Yeah, and I would like to say that it can this randomness that is accumulated by the beacon chain is pretty with pretty strong properties, coming with pretty strong properties with respect to what the block hash can give, but it depends, of course, on how the application is designed that use it. It can be designed in completely unsecure way, like using the already published RANDAO mix, and that's the way it should not be. That's the way it should not be designed. Also, yeah, if anyone wants to try it out, there is already the Kintsugi testnet that is already in progress and in place. You can try it out there. It's this EIP is a part of the Kintsugi spec, so all of the clients have implemented it, and it's for it. Just go and try it out.
Interesting, yes. And we also have recorded an episode on Kintsugi testnet with Paritosh and Fruto for people who want to have a little bit more background on that and want to learn how to participate. Please go check out the documents which are listed in the description section. All right, moving on to the question and answer section. I have a follow-up question on the backward compatibility. So if I understand correctly, the idea of preserving the difficulty instruction numbers for the new random opcode is to support the existing smart contracts. So they will be able to use the EVM instruction with the same number as source of randomness output, irrespective of whether merge has happened or not. I mean, there was also a pointer which can actually indicate when it is being on the POS chain. Yet I found that some of the comments at discussion 2 section, the link that we have for FEM, suggests that some of the dApp devs are not very happy or maybe not very confident with the proposal. So I'm wondering, do you think it's a concern that should be addressed, or is there anything that could be done to have them on board in terms of creating awareness of utility or importance, or maybe the plus and minus point of the proposal?
Yeah, that's a good point. First of all, we have this discussion thread in the link is in the EIP. If you think that something, yeah, first of all, if you think that your app, if your existing application will be affected much by this change, so just reach us out in the Discord, in the ether in the Discord, and let's discuss it there. Also, you might want to visit the merge community calls that are happening. I'm not sure if they are happening on the some constant basis in terms of timeline. So, but anyway, they're announced in the Discord, so you can follow up, appear there, and let's just discuss. I'm always open for discussion, so reach me out directly. Any of these, I'm not sure that there is, like, you know, all the concerns that are addressed, all the concerns of the developers are addressed. But if you have them, please appear, and yeah, let's start working on it, because it soon will be moved on. And yeah, we want to hear from everyone who is affected.
Right. And just
now
to add, and just to add on here, the merge community call that Mikhail is talking about generally happens once a month. We had the call, I think, in early December, 3rd or 4th December, and the recording is available on Ethereum Catalyst YouTube. We'll be planning another one in early January or somewhere around that. So it would be nice to have you guys around and share your concerns. All right, so my next question is related to security consideration, though you already have partly answered the question that I originally had. So we discussed the downside of the randomness output returned by the random opcode that reveals to the network within the parent block. Would you see this? I mean, like in terms of a project, like you explained with a lottery system, it doesn't seem very harmful. When we look at from the application side, the lottery side, would you see it creating any vulnerability to the chain or any other downside that possibly could be there?
I don't think so. I don't think that difficulty, basically the difficulty gives like very strong randomness. Currently, it's pretty much predictable because the difficulty is computed out of the difficulty formula, and it can be predicted, and in a much more feasible way than this RANDAO mixes. So I think that what have been discussed today in this example should be like in the security consideration. Like to give an idea to dApp developers, to people, how this should be properly used to avoid this, insecurity, to avoid the lack of security for the applications that use this random opcode. I don't think that it will really affect this change. If we consider the difficulty as the source of randomness, the difficulty opcode, this EIP, this change, the merge with this EIP will not affect the security.
That's really good to know. I know, I mean, like every proposal that is approved by the core developer or the client team is generally thoroughly vetted. Just had a curious question. So thank you for your answer. So my next question is related to reference implementation. As you mentioned that this proposal is already implemented in most of the clients and it's live on the Kintsugi testnet. I find the section as TBD. So I was just curious, like, do we plan to add maybe reference links over there for the different implementation in different clients?
Yeah, I think so. Once we move this proposal to the reviews status, to the review stage, we'll probably add this links to the existing implementations, or to one or two, or I don't know, probably to every of them, whatever is suitable.
Right. And there is another small question, which is again related to the proposal. It's about the test cases. So it's good. Like, I understand that testing the functionality may go beyond the EIP documentation, but I was just wondering, like, it would be nice to have pointers where people can follow. I'm not saying that this is a requirement for a proposal to move to the next status, but just wondering if we can have the link that can be added for a reference for this EIP.
Yeah, sure.
Yeah, that would be nice to have. And like, as you mentioned about the EIP status, this EIP is still in draft, like, and is already implemented and is being tested. So as an author, do you think it would be like a good time to move to the review status, like, soon?
Yeah, one thing I would like to add there, as I mentioned, this security consideration stuff, to explain more about the randomness properties, and yeah, basically these properties, like, probably with more wording and more clear way, and I think then we can move it to review. And yeah, when it will happen, I expect that this will happen like kind of in February. So, and this one will this EIP, as it depends on 3675, their status will be changed, I think, at the same time. So to avoid the case when the EIP 3675, which is the dependency for this one, is yet in draft state, and this one is in review state. So basically you can't review it before the 3675 will be ready for review as well. And yeah, regarding testing, one thing here, yeah, it's not that obvious because it involves basically the consensus layer that provides this RANDAO mix for the random opcode, the value for the random opcode, and yeah, and it involves also obviously the execution layer. So there will be like integration test cases, and yeah, probably not only integration. So yeah, it's a bit not usual for this kind of stuff, like, because it involves like two layers.
Right. Yeah, right. And you rightly mentioned that this EIP 4399 is having a requirement of EIP 3675, and it is already mentioned in the proposal that they both are supposed to be deployed at the same time on the mainnet. That's fair enough, but I understand you are also the co-author of the EIP 3675. So I would be curious and maybe, wondering like how soon can we expect that proposal to be in review? Because I know it cannot go into last call as of now, but because we have moved to more advanced stages and it's being there for even testing. So what do you think?
Yeah, I think it's both will be moved to the next stage in February or this kind of time. So after we get back from holidays, we'll get some refinements and more close work on the spec. Then I think it will be ready by the end of January. So that's why this is really, it will be ready by the end of January, and that's why it's like, if you have any concerns, please raise them as soon as possible, because there is not that much time left.
That's right. So this proposal is already in the first testnet. So if you have any concern or if you want any further modification in the proposal, please feel free to join any of the discords. The ETH R&D discord is one of the best one to talk about, or join the community calls. I see Shubhangi has a question. Shubhangi, please go ahead.
Hi, thank you for the opportunity. I just had a quick question about the semantic meaning of the word random used for the proposal, and there seem to be some opinions on the forum that some developers may be confused and use and the proposal may be used incorrectly. And what are your thoughts about that?
Yeah, that's tricky. That's a good question. Yeah, it's pretty tricky. So there was like a proposal to call it the P-random, which is the randomness. And yeah, I don't think that this is really what I would say is that every randomness oracle, especially in the distributed setup and the distributed systems, is not like a simple thing, and what's behind this randomness oracle should be carefully read in the spec and all the security consideration and so forth. And I don't think that, even though if we call this p-random or in any other kind of way to give like a direction of thoughts of the real source of the value that this opcode returns, that will give like you much understanding and much awareness of how it should be used. So it's called random just for simplicity. And what does mean random in this particular setup and this particular system is better read from the description, and the description of this proposal and the specification and the security considerations. So that's, I don't think, yeah, I see the intention, I see the sentiment here, but I really don't think that it makes much sense to use anything other than random here, because you will anyway, whatever is used, you will have to go and read the spec and understand how does it work, and understand how can you use this in a safe and a secure way. That's my opinion.
Thank you.
All right. Thank you, Mikhail, once again for joining us and talking about this very important proposal for the upcoming upgrade. And thanks to all our cat herders for adding these questions to make it even more interesting. I hope the information shared today will be useful for the dApp devs, especially where the project is using any form of difficulty to generate the randomness in the project. Any final comment from you, Mikhail, for the community related to merge?
Yeah, have a great holidays, everyone. It's a pleasure to be a part of the community and to work here. And the next year is going to be a big one. Basically, every year is a big one, but the next one will be like the year of the merge, which is very exciting. So have a great holiday, take a rest, and be prepared for moving on.
Right. Thank you. Well, we hope that that following the merge episodes that we have recorded so far in PEEPanEIP will inspire more users to join the merge public testnet and experiment with the post-merge experience. I hope this proposal 4399 and even the proposal 3675 to be moving up to the review status and eventually become final when the upgrade is deployed on the mainnet. On this note, thank you viewers for watching this episode. If you like it, please hit the like button and share it with the rest of your community members. Slides, discussion too, and other related links, along with guest Twitter to follow, are provided in the description section. Should you have any question or anything you want to ask, or you want to suggest some proposal to be discussed in future episodes, please leave us a comment or share with us in the Calendar Discord. I would like to take a moment to thank all our guests and ECH contributors and YouTube viewers for your love, support throughout this year. Today is the last recording for PEEPanEIP for this year. It's been fun making these information-rich episodes available for community, and we hope to continue getting more learning in the year 2022. Subscribe to the Ethereum Candidates YouTube channel if you haven't done it already. See you in January. Have a good one, everyone. Happy holidays. Happy New Year ahead.
So thanks, Pooja. Thanks, everyone.